Hello, everyone, and thank you for this opportunity to serve CONAC-D, the National Data Science, and your growing community. This session will cover modernizing the analytics and data science lifecycle for the scalable enterprise using the SEAL method. That stands for Scalable Enterprise Analytics Lifecycle. My name is Jeff Bertman, and I'm CTO and Head of Engineering and Analytics for Defuse Technologies, a consultancy largely focused on data. Defuse actually stands for Data Fusion. Formerly, I was a Director of Data for Warner Brothers Digital Networks. So we have a dual presentation today, a treat, where we're bringing in another speaker, Christian Bordeaux. He's with Sony PlayStation, and formerly with Nike and Warner Brothers, where we work together. Christian will expand on the visualization and business intelligence BI aspects of analytic environments and how to enter the workforce, particularly from college. Chris actually is an assistant instructor as well for University of Southern California, USC. So his presentation is called How to Become a BI Analyst. We'll chime in on each other's presentations a little bit, but each of us will be the main speaker for our respective parts. I'll be taking the first part. So if you think about it, there's two basic messages here collectively. One is how to target, or I'm sorry, how to get your work done effectively, efficiently, reproducibly, and then when we segue to Chris, it's basically how to get paid for it. All right.
Nice.
Now, I'm sorry, Chris, what's that?
I was like, nice. And you know what, Jeff, I'm super excited to get started and, share all of this immeasurable wealth of data.
Yeah. Okay. So before we move on, I just wanted to mention that kind of both our decks coming from Warner Brothers and just living in Hollywood land, so to speak, have a little bit of Hollywood glitz. So some people might like it, other people might find it different. All right, here's the agenda. We'll give a little bit more a little bit more of an introduction and a review of credentials and so forth. Then we'll set the stage so that we understand why do we need a life cycle and why does it need to be modernized. We'll discuss the business and technical landscape, starting with goals and then getting into the environment so we can kind of see how technical environments have evolved over time and again, why we need to modernize. Then we'll present the existing methodologies in the workplace, including SEAL. So you can see how SEAL stands up to CRISP-DM, which it is based on, as well as a couple of alternatives from Microsoft and SAS and so forth. Finally, we'll present some cool and emerging technologies that are relevant to this space and get into some Q&A. This is a pre-recorded session, so the Q&A will kind of be appended later. After this presentation, we will segue over to Chris's presentation. And again, each of us will chime in a little bit with each other. This is just a little friendly icon in the top right for a different presentation I have about building big business with big data. I thought it was kind of cute, so I threw it in here. Oh yeah, keep in mind, future updates of this deck will be available at the links provided on the first and last pages of the deck. And there's also an underlying white paper. And some of the slides are a little dense. Let me get to that on the next screen here. These are notes to the audience. This deck can be used in two different ways. One is obviously what we're doing now through video and presenting it. Another is obviously using it offline as a resource. And because it's kind of married to this white paper, there are some slides that have a lot of information. Sometimes the deck is ahead of the white paper, sometimes the white paper is ahead of the deck. So for that reason, I have animations in the deck so that you can see information gradually without being bombarded by a bunch of detail. So when you're reviewing the deck offline, you might choose the PowerPoint instead of the PDF. It's a little bit easier to understand in that way. All right, let's see. All right, credentials. Again, I'm with Defuse Technologies. Just a few takeaways here. In addition to our data boutique, we're ranked number 84 in the Inc. 5000 for IT services and number 107 in development. That's for 2019 and 2020. A bunch of other credentials. We don't have to get into all all the stuff here, but we do work in the Fortune 1000, Fortune 100 space. Here are some of our customers: Apple, CVS Health, Amgen Pharmaceuticals, a lot of health and banking, E&Y, Wells Fargo. We just brought on Fidelity recently, and a lot of federal government work. And my background also includes a lot of work at Verizon, Comcast, Cigna, Geico, and whatnot. And then I'd like to just call out a special item here at the end. Throughout this presentation and a lot of our presentations, we focus on ROI, return on investment, which basically means always thinking about cost benefit when we do things. And a life cycle is one of the best places where we ensure that that happens. All right, here's my personal background. We mentioned Warner Brothers and a few of these other places, I should say. I spent many years at all of them. These are not just casual engagements. At Verizon, we saved $100 million in a 13-month period. At Geico, we built all of their internet analytics from scratch. I have some credentials at the bottom. And here's a summary of accomplishments over there on the right. We're not going to cover them during this presentation. Okay, this is a warning about the glitz. So be, forewarned. There'll be slides that maybe introduce Bugs Bunny. I don't know if you can see that right now. Let me move this a little bit. There we go. Here's Bugs Bunny. We got Machinima, which is a gaming environment, and I threw Defuse in here. We're more conservative, working for the federal government as well, but still fun. Okay, now on with the core part of the presentation. So here's the abstract you've probably seen by now. It's no secret that the roots of data science date back to the 1960s, which is basically when we first started applying statistics to the world of business computing and computing for scientific environments as well. So in the 1990s, that was later formalized into the field of data mining. Data mining, in a nutshell, is basically extending statistics from just trend analysis to discover trends that humans typically would not think about. So instead of the traditional what-if analysis that I'll talk about soon, we let machines and math help us find trends that we would not normally or intuitively think about. Before I get into a little example about that, I wanted to set some context to why we want to modernize what we've done in the 1990s. So in the 1990s, that's when CRISP DM was formulated. We'll learn about that soon. The cross-industry standard process for data mining. Back then, a lot of data was 1 terabyte. That was called a VLDB, very large database. And you had maybe 1 to 3 enterprise databases in your enterprise. It could be Oracle or IBM or Microsoft. Maybe you had some open source in there, MySQL or Postgres. And now, today, instead of 1 terabyte of data, we have at least tens or hundreds of terabytes, if not petabytes of data. Huge distinction, much more data volume. We also have data variety and some other V's that we associate with big data. We'll see that stuff soon. And very complex environments. We have the cloud, hybrid, multi-cloud. We have probably at least a dozen data platforms and different types of file systems and so forth that we use for data. And then integration tools and things. We're going to see what this landscape looks like pretty soon. But this is one of the reasons why we now need to modernize the methodologies that were used back then and segue to something like SEAL. Now, here is that example I was saving about data mining. It's all about finding patterns that you would not normally expect. And this is a classic textbook example where beer and diapers actually have an affinity to sell together. Normally, you wouldn't expect that. If you have an online store and you want to make a recommendation engine, encourage cross-sells and so forth, in addition to diapers that someone's looking at, you might display images of diaper creams and pacifiers and other baby goods and whatnot. You wouldn't think to display beer at the same time. But this example dates back to space management in retail establishments, where it was discovered that there is an affinity. And if you think about it in hindsight, we can justify this by saying, hey, and this is a little stereotypical, but it also dates back to more stereotypical days. The wife calls the husband, on your way home, pick up some diapers, and while he's at the quick store, he picks up some beer as well. Presumably, if you collate those two items a little bit closer together, you would magnify that effect and sell more beer. You can do the same thing with online stores and recommendation engines. If you're looking for camping supplies, maybe you also see something about dog, leashes and dog supplies and things like that, because there happen to be an affinity of camping. And people who like pets, dogs in particular, happen to do well in camping environments. Okay, moving forward. In recent years, this is an example of the large aspect and the variety of data that we're just talking about, from 1 terabyte to petabytes and so forth. This is thousands, millions, and billions of records in a typical environment. This environment just happens to be an example for Warner Brothers Digital Networks. We have thousands of content creators that end up providing millions of videos with billions of aggregate views per month. Many environments are just like this, and all these different technologies that I was just talking about earlier. This is, again, a reason why we need to modernize and accommodate the volume of data and the diversity of all these technologies that work together, and how to integrate this into your environment in a methodical way. We have to modernize. Okay, so the goal in general for analytics is to improve business outcomes in our organization by leveraging our analytics or data science practices to deliver results consistently and obviously of high quality, on or ahead of time, and on or under budget. Simple as that. Now, what do we mean by business outcomes? Basically, for commercial organizations, we're improving revenue, profit, market share, and so forth. For government, and also as applies to certain commercial establishments, you're looking at mission effectiveness, fulfillment, efficiencies, quality, safety, security, you name it. There are a lot of KPIs that are involved in business outcomes. We have certain challenges and solutions. So in order to make all this happen, we obviously want to execute with a certain speed and agility. At the same time, we want to balance that with being thorough and accurate. Now that's where the quality comes in. So with SEAL, we have a life cycle that is agile, but also has checkpoints to assure the due diligence. And it's also an agile life cycle. So you see in parts of SEAL that we use only the parts that we need. You don't always have to think about how to keep it lean. In some cases, it's shown right there on the screen for you. You'll see that soon. We also want to balance innovation with being practical, pragmatics. So we have a hybrid solutioning angle where we combine business and technology, kind of use our goals and business thinking from the top down, and we triangulate to improve our accuracy, and that's how we execute ahead of time or on time and on or under budget. By planning from the top down, but by understanding the nuts and bolts of the technology and triangulating from the bottom up. We also introduce certain economies of scale. For example, a typical data science environment uses just data scientists, but we're going to talk about how to blend in other labor force, other huge elements of your labor force, such as data analysts and business analysts. They understand the business environment. They should be integrated into your analytic studies so you can have self-service. And once you make all that happen and you combine all of these types of people together, you get the best type of economy of scale. So you have your formal data scientists sharing data assets and even control flows or whatever is necessary with your business analysts and your data analysts. This is just a lot of details. Again, if you read this deck separately, aside of the video, you can get some extra information here, but pretty much we covered it verbally. Here is an example of a business and the different pillars in that business or in the enterprise. So the first pillar is what is us, the analytics and data science and BI people. You have other departments and organizations that handle finance and accounting, marketing, sales, biz ops, business operations. Depending on the type of company you have, like at Warner Brothers, we obviously have studio programming and talent management and so forth. Other companies that are inventory related might have supply chain optimization, fraud detection, and whatnot. And naturally, you have some miscellaneous but still critical departments to handle security and legal and IT itself. Sometimes you want to optimize your IT practices, not just your business practices. These horizontal layers are all about how we get the work done, right? We execute best practices, we leverage technology, we convert data into information and ultimately into action. And at the bottom here, we just have some credos, obviously focus on cost benefit. And personally, I like to treat everyone as a customer, our obvious customers. So if you're in a store or a retail establishment, those are your consumers. But really, these other pillars are customers too. When you're a data scientist or a data engineer or whoever, you might thrive here, but you're serving the other pillars in your organization. All right, this is what I call a value scape. It's a typical pyramid, just like a lot of pyramids people make all the time. But what's different about it is I like to make the business value triangle at the top big and green and overhang everything below it. Everything below it is just the technology enablers. This is where we work every day. But this is what we're producing, the end result, the KPIs we're talking about, improving revenue, profit, market share, and mission fulfillment and things like that. Here is a data-centric version of that pyramid, and it outlines certain specific components that we'll see once we get to the technical landscape. But this kind of shows it in a hierarchy, right? We have our generic infrastructure at the bottom, our storage and networks and so forth. Later, we introduce our technical tools such as data integration, data virtualization. We'll cover this later. Our visualization tools and actualization tools. So not just visualizing the results of our analytics, but also feeding those results to other systems for alerting purposes. Hey, profitability in a certain region is lower than expected, right? And those expectations themselves can be determined by AI and ML processes. So this is basically how everything fits together and once again accomplishes the business value at the top of the pyramid. All right, so we talked a little bit about ROI earlier, and this is just a favorite comic where you can see all the people at the conference table, analytics and AI and governance and data quality and so forth. They're all there, DevSecOps, but the ROI seat is empty. Where is this guy? Well, we all talk about ROI a lot, return on investment, but it's not always calculated. How can you calculate, for example, customer satisfaction? It's difficult. So one thing that we've actually formulated at Diffuse is a methodology to simplify ROI. And we have another presentation series called Maximizing ROI in Big Data and Analytic Environments. Next year, I'm going to brand that as the ROI Ascendancy Model. But the net takeaway here is there are simple ways to make ROI a part of every story, as it should be. Let's see. Okay, I'm not going to get into all that reading stuff. If you want to, once again, you can read the deck. I'm covering a lot of it as we speak. All right. I talked a little bit about the ROI ascendancy model. Here are some key takeaways. Um, it probably sounds familiar. You probably have heard about the Gartner analytics ascendancy model. It also is an ascending model of maturity, where you start thinking at a rudimentary level like descriptive analytics, and ultimately at the top of the analytic ascendancy model, you have predictive and prescriptive analytics, much more mature. Same thing here. At the bottom of ROI thinking, we have the direct costs associated with whatever it is that you're buying or investing in. And later on, you start thinking, what about the indirect costs? And then, how do we make this continually improve over time? I also have a pictorial way to think about it, where this is a package view at the bottom. Later on, we start thinking circular, laterally, if you will, spherically, and then multiple spheres. This is all presented in a different deck, but I just wanted to raise the idea that ROI is integrated into the SEAL methodology as well. And for government people or people familiar with the Software Engineering Institute, there's another process called the CMMI methodology, the Capability Maturity Model. And I kind of avoided it, except when necessary for government projects, until more recently. In 2019, they actually improved it in significant ways to make it agile. Until then, it was kind of bloated, in my personal opinion. And now it's being popularized again in 2020, now that this version 2 has come out. And it also starts at a rudimentary basis. At the bottom here, you start with success from heroics. Later, you want to make things reproducible, and you want to be able to measure and control, and then eventually have continual improvement, just like we do in SEAL. Okay. All right, here is a simple landscape of how data flows in an enterprise. This was pretty much the way things worked in the 1990s, and they still work today, but we're going to introduce some innovative ideas on top of this. But let's learn the basics first. We get data from our sources, we ingest it, we execute data integration or ETL processes against it. We call that prepare and blend in data science environments. It goes into a lake. At one time, that used to be called an operational data store, and there are some differences, but the idea is that it's mainly raw data that you can execute intelligence against, but it's still basically raw, although you've consolidated or reconciled the data in some way, perhaps. Ultimately, you blend and transform that data into a hub. That's a modern term for a data warehouse or a collection of data marts. This is a data refinery. And ultimately, you present the data or you actualize it in some way. Remember, from our pyramid, we're talking about it's not always about visualizations. We might have an alerting framework, the profitability example, and so forth. So this is all great, but it takes a lot of time to make all this stuff happen, and good people and processes. Now, in a modern environment, we like to take shortcuts. We always like shortcuts. So these purple lines are ways that, kind of patterns that we can access data faster. We also have power tools, if you will. So these turbo circles at the bottom accelerate the standard data path. So there's multiple ways that we can speed things up. I will talk about the distinction between custom and turbo soon, but in the meantime, let me explain. When we take shortcuts, we get what we want quite often, but we also get some things we don't want. Technical debt. So let's say that I have a one-off analysis that I'm doing. This is around the presidential election times. Not that long ago, we were in the middle of presidential debates. And there's a product out there called Scalar that has a pretty good video on how they do sentiment analysis after a presidential debate. They scan Twitter and they see, what candidate seems to have won based on their remarks and blah, blah, blah. So they do that study as a one-off. And in this case, one presidential candidate won over another presidential candidate, and you get really quick results. Now, later on, what happens when you want to compare that debate to another debate between the same two candidates or between two different presidential candidates in the past, or 5 different presidential candidates or whatever? Year-over-year analysis, month-over-month analysis, comparisons across campaigns, across consumer segments, or any other types of segmentation. All of those things are best done when you organize the data in some kind of warehouse or hub or data mart. When you're just storing those one-off studies in your data lake, that one-off is successful, but later on when you want to compare the information in all those different ways, it gets pretty difficult. You have to be kind of meticulous about the way you store things in your lake, and invariably you end up with what are called data silos, as well as data swamps. And you've probably heard about those terms. That's what happens. So you need methods to make sure that you kind of get the best of both worlds. You can expedite processes with these purple lines, but you can always count on not losing track of your data. Losing track can be quite expensive. Forget about the inability to do year over year and month over month and all those other comparative analysis I was talking about. What ends up happening quite often is you end up kind of forgetting about that data and letting it sit there, and then you're paying for it. And that is very expensive as well. Of course, you can set up rules in your environment, if the data hasn't been accessed in so long, have it show up in a report or automatically tier it off to less expensive storage and whatnot. But it still costs money. All right, so there are some underlying details here. I guess we've discussed everything that I just popped up, but now let me reveal these circles, right? The custom and the turbo circles you can see. On the custom side, you have basically coding, right? Python, R, and so forth, and using a lot of tools, Spark and Presto, at their lower levels. Then with Turbo, you can layer power tools on top of it, basically, right? So I can use Talend or Pentaho, to do ingest and preparation and blending of data. I can use Alteryx, which is a citizen data science tool that allows power users, business analysts even, to do some pretty sophisticated data engineering work. And ultimately, the same tool up here in the analysis side will let you analyze data. We'll talk a little bit more about citizen data science later. So anyway, I don't want to dwell on this slide anymore. Let's move on. Okay, here is a particularly non-aesthetic looking diagram, but it's intentional. I just wanted to give you an idea of sometimes what I call the stew. This is an actual environment that we converted. It's a sanitized environment, so there's nothing proprietary here, but it is based on reality. We converted from 100% on-prem to about 99% cloud. There's still a little bit of a hybrid going on in this particular environment, and in other customers sometimes we'll just do a 50-50. But the point is, everything that was converted to the cloud is in green. So I wanted that to stand out as a sore thumb. And this shows all the different tiers in your environment. Here are your data sources and ultimately your results on the right-hand side. And you have all this orchestration going on down here, your Git for version control and backup tools and your low-cost storage and data integration, all this other stuff, right? Bottom line is, this environment supports a combination of analytics and operations, transactional systems. On the analytics side, you're driving, your visualizations and your alerting frameworks and stuff that we've already talked about. On the operational side, in addition to transactional systems like accounting and ERP and CRM and whatnot, you also have operational analytics. That's a field where maybe you have a stream of data coming in, like those Twitter feeds I was talking about. In this case, operational analytics applies to very high throughput, such as a million rows or a million records of data in a second. There are tools that we'll learn about later. MemSQL is an example of a tool that excels in this space. Redis is another example. I happen to lean a little bit more toward MemSQL because it's SQL compatible. You don't have to have an API to access the data. So the point is, whether you're dealing with standard analytic applications or operational analytics, you still typically have many opportunities to integrate AI and machine learning. An operational analytic environment could be fraud detection. You have to analyze, at least thousands of credit card transactions per second. In less than a second, you need very fast response time. That's an operational analytic environment. And when you have high-risk merchants, there's a lot of decisioning that has to go on behind the scenes. It's not just, oh, okay, is the credit card good? But there could be information about the merchant and bank rating, credit score ratings, or whatever else that might come into play that you have to analyze in very short time. That's an AI type of activity, machine learning. Okay, now moving on. Let's dig in to the data science, data analytic methodologies themselves. This is where Chris is going to chime in, but we've ended up recording this in two pieces. So instead of him chiming in on each one of these screens, I'm going to finish my presentation, and then we're going to have Chris join us and kind of walk through the different levels of CRISP. Chris helping us with CRISP. I'm sorry, but really more so, he's going to help us with SEAL. Let's start with CRISP, and we'll see how all of this is modernized in SEAL. So, CRISP DM, the cross-industry standard process for data mining. We started at the top with business understanding and data understanding, and all that makes sense, of course. Ultimately, we have to prepare the data in some way. We model it. This is the part where the data science fun resides, so to speak. This is where you're deciding it's going to be supervised learning or unsupervised learning. Unsupervised is typical for image recognition or video recognition activities. And anyway, that's a little bit beyond the scope of this presentation. But the point is, this part is fun, but there's room for error, right? We have to evaluate all the fun that we did in this evaluation phase and see if we were effective. If not, then you see an arrow that kind of takes us back to the drawing board and we start again. Ultimately, we end up with something successful and we deploy it. There is no feedback loop in CRISP. After we deploy, we don't continue learning. There's no accommodation for things that happen that we know go wrong in data science environments. We'll talk about model drift, for example, later on. We'll talk about, maybe we had to impute certain data that was not available in our sources for model training purposes. And the data that we imputed might have been good for the initial implementation, but over time it didn't work. We might have seasonal situations. Whatever the point, whatever the story, the point is, after we deploy, it's kind of a dead end here with CRISP. There are a variety of options that people have come up with over the years to try to modernize CRISP. They're from popular institutions, but they haven't caught on in widespread ways yet. And of course, there are exceptions to that. I'm sure at some institutions, Microsoft TDSP, for example, might be used religiously, but for the most part, a lot of people use CRISP DM. Here is an example, actually. I think I have this up in my web browser. This is an article, Why Using CRISP DM Will Make You a Better Data Scientist. Here's that diagram that you saw. This is as recent as December 2019. And there are other articles. These are all recent articles about CRISP, and you can even see it was created in 1996, 1997-ish. So the SAS Institute came up with something more modern called SEMA, the Sample, Explore, Modify, Model Assessment. IBM has ASIM-DM, Microsoft has TDSP, their Team Data Science Process Lifecycle. I recently discovered this collective university study in Germany and South Korea called CRISP MLQ. The Q stands for its focus on quality. My personal favorite happens to be Microsoft TDSP, and I think I have that here. Yeah, here it is. This is the Microsoft TDSP methodology. It looks a little scattered, but it's actually pretty good. And we've incorporated everything from TDSP and everything that I deem relevant from these other methodologies into SEAL in what I think is a simpler way, and it's the feedback that we're getting from everyone also. So here is why these methodologies have fallen short so far. One reason is that people associate these methodologies above, from SAS, IBM, and Microsoft and whatnot, with the proprietary tools, which isn't always the case, but there is a certain association with SAS, for example. I've seen that firsthand. And Microsoft, naturally, they talk about their tools, but you can apply them to other methodologies, but there are still additional gaps. What are they? Is there a formal way to account for scalability and performance? We've already justified why addressing scalability and performance in these big data environments is important. Not so much accountability and SLAs. And when we talk about SLAs, people think about performance and availability, but there's more than that. There's quality and security SLAs and whatnot. So CRISP has ways to formally checkpoint these things. The integration with DevSecOps, which is basically a combination of DevOps and security and compliances. Something I'll call holistic QA, we'll get into a little bit later. And of course, continual improvement is a big theme in SEAL. As well as, remember we talked about economy of scale. SEAL will allow us to unite our data scientists and our citizen data scientists, all those business analysts and data analysts who understand the data and the business and should be allowed in a self-service environment to achieve data science caliber results and to use the same life cycle so that we can guide them and predict their success and guide their success consistently. All of these methodologies have links, just like many other places in this deck. You can click on links and learn a lot more. So there's one for each one of these methodologies, as well as the underlying white paper for SEAL. All right, here we juxtapose CRISP-DM with SEAL, and you can see at a high level, the basic flow is the same. But we're going to have a diagram a little bit later where you can actually see the lingo of each one of these boxes from CRISP appear in the lower levels of SEAL. But at a high level, we can see that we have a feedback loop now, so that when we deploy something, we learn from it, we feed it into continual improvement to help future projects. Also, after it's deployed, we can still learn from business and data understanding, directly feeding our deployment or production environment. And we have iterations in each one of these boxes also, as indicated by these closed loops here. Now let's dig in a little bit. All right. I think I covered these highlights here. SEAL is multifaceted in that it combines data science and citizen data science, and it accommodates more modern reference architectures. We'll talk about or actually we already saw the technical landscapes with a lot of those tools and technologies. And we talked about SLAs and so forth. Let me dig in a little bit deeper, and you can see the parallels between CRISP and SEAL. So here we have the business and data understanding that we talked about earlier. You can see the same exact boxes now in SEAL. They're in this defined charter and goals phase one. and data preparation is also here. But we've added in data acquisition and blending. In the modeling phase, we have it here too, and we distinguish between AI, ML modeling, and I think I showed this diagram before. Hold on for a second, maybe not. Yeah, here's an example of model selection, right? This is a decision tree, and it helps us decide, are we going to use some form of regression analysis, multi-class classification, or just two-class or binary classification that's sometimes called, clustering. At a high level, basically, some kind of supervised or unsupervised or other type of learning models. And it's not just this Microsoft cheat sheet that you can use. There's also decision trees like this for SaaS and other products. But a lot of it is actually generic. And that's what this box is about. Which model am I going to choose? And we're going to learn that it doesn't have to be a human choice. There are tools out there that will help you do this automatically called auto ML tools. Here we have a box right next to it for analytic solutioning. This is where you have the citizen data science people work. They're not getting into all of this algorithmic selection for the models. They're just dragging and dropping and letting the tool kind of do it for you. But we wanted to include the business analyst, data analyst, the citizen data scientist, if you will, in the same life cycle. This is where it starts, in the analytic solutioning box. Okay. Now, I've already started making some of these callouts, but let me take a step back so we can actually see what's going on. Here are 10 callouts of things that are in SEAL that aren't in CRISP, and a lot of them also aren't in some of those other methodologies. We're going to walk through these, okay? So at the top level, we have business and data understanding. I just wanted to emphasize, in addition to the generic concept of understanding data, we're formally going to checklist certain things. We're going to define goals. We're going to define a value proposition summary, get an idea of what our cost, benefit, and risks are. And if necessary, we'll define some service level agreements that we touched on earlier. This is an example charter of how to make all that happen. It's based on an industry standard called the Business Strategy Canvas, BSC. That's an overloaded term, by the way. BSC also happens to be an acronym for Balanced Scorecard. That's not what we're using here. Think of this level, this charter level here, as also what I call a minimum viable understanding. A lot of people are probably already familiar with the concept of a minimum viable product. That's like phase one pilot type of product that you deliver. Well, this is kind of an early concept definition, something that you could ultimately use to create a product requirements document if you're in the product space. That's called a PRD. So that's the level of thinking here, right? We're defining our goals and our opportunities, and is it going to fulfill or involve marketing, finance? Is it going to involve the improvement of a product that we're selling or manufacturing or whatever? And there are certain parts of the business strategy canvas that actually, there are certain parts of SEAL that are not included in the business strategy canvas. Cost benefit at a glance information like this is one of them. But I like at a glance concepts. So when I look at some kind of write-up, I want to see at a glance, is it cost effective and is it low or high risk? So here at the business level, I can see for this hypothetical example that we have a low cost of 2, 5 would be high. We have benefit of 5, which is great, and we have a very low risk of 1. The technical is a little bit higher cost, a little bit higher risk, but still a benefit of 5. Therefore, the value proposition for this hypothetical project that we're going to pursue is high. And I guess because the value prop is high, we happen to give it a high priority too. Let's get it out the door. All right. Another part of the charter involves a SWOT summary. And remember, we only use the parts of all of this stuff that make sense for our data story. I'm going to make that note go away, but just keep in mind it's a lean methodology, so use only what you need. I happen to like SWOT. You can identify strengths and weaknesses and opportunities. For example, a strength is you're going to make a lot of money on something, but weakness might mean, it's going to depend on external data. You don't have access to it yet. You pretty much know where to get it, but you don't know if it's going to be reliable. You heard maybe that there are concerns about the reliability, but it's worth exploring. So that's a weakness as an example. The value proposition, the business strategy canvas has no specific way to handle that. I happen to like a Zachman mindset, who, what, when, where, why. And I like to throw in a little bit of a business value validation. Ultimately, how are we going to make sure that this project is successful? You can proactively verify this, often using an AI or ML predictive method, and reactively, or after deployment, you want to verify that something was successful. That could be as simple as a survey that is sent out. What does the customer think? Not just what do we think. What do we notice from the numbers? Because if the customer has concerns, even though the numbers went up, you might have a lot of extra opportunity to make the numbers even better. And that's why reactive is so important. The rest of this charter is about risks and mitigations, and what are we touching, sales, distribution, and the government. We might involve command and control in a military environment, for example. What partners do we need? We talked earlier about involving external data from a vendor, so we can provide a little bit more detail about that here. This seems like it's kind of thick. I just want to get into my analytics and start mining and start making conclusions about our study. Someone in your organization is doing this in order to ensure that you're going to have success and minimal surprises. So it might not be you at the beginning of your career. It could be your manager or some director or whatever. So as we're proceeding in this, if you're getting the idea that it's kind of thick, I just wanted to lay that idea out there. Key resources and activities that are involved. Obviously, what type of customer segments and relationships are you studying? What's the cost structure and how are we going to make money off of this, the monetization scheme? Is it going to be recurring revenue? Is it going to be a one-time thing? Is it going to be subject to some kind of seasonality or a surge that's temporary? We're going to discuss an example about hurricanes that come in, and we want to use AI and machine learning to predict where the highest degree of damage is. We're not going to replace NOAA, the National Oceanic and Atmospheric Agency or association. I forget exactly what NOAA stands for, but that's basically the weather organization that helps predict where storms are going to hit, and they show a cone and whatnot. That's not our job, but we can use data from NOAA and combine it with data from other sources. So we talked about getting data from another vendor. We have these mashups that help us understand, and then part 3 takes us into that picture where we can actually see, in addition to the data I'm using here, I'm going to combine data externally. So I'll combine data from NOAA about the storm surge, say, it's going to hit, according to NOAA, this area, and there's going to be a certain amount of flooding from the hurricane and whatnot. Now let's also get data from a variety of other sources to figure out what properties are going to be more vulnerable to the flooding. So older properties where appliances like air conditioners and refrigerators and whatnot, or the house itself, were not elevated, that is going to be more susceptible. In modern houses in flood-prone areas, you actually put appliances higher, so there's not as much damage to expensive machinery. And there are certain walls of houses now that are designed to blow away so that the whole house doesn't get blown away. So you can look at the age of certain buildings to help predict, okay, there's going to be more damage here than in these other places. So now we can direct or triage resources like service contractors into those areas, prepare them in advance so that we can recover from a storm much faster than normal. This type of process is made available because of the blending of data and combining all of these different sources and forecasting where the damage is going to be based on data that you have available. It's an AI framework. The last thing that we might include in a charter are the SLAs that we've already talked about. Okay, here's a little wake up. Just in case you fell asleep, because the rest of this is going to be a little bit easier. Let's get into the subsequent parts of SEAL. Before that, I just wanted to set the stage that data scientists, data engineers, DevOps people, application developers, they're different people, but they have overlapping territory. And this is another reason we need to modernize our environments. At one time, there wasn't as much overlap. There's the concept of DevOps itself is relatively new. So SEAL accommodates all of this overlap. And of course, sometimes you have one person wearing multiple hats. Sometimes in a big enterprise, you definitely have different people. All right. So moving on with the rest of SEAL, we can get into the wrangling and refining of data. Here we've added not just the preparation, but the acquisition and blending like we talked about earlier. We've already talked about the AI and the analytic solutioning, so I'm not going to linger on that anymore. Let's move on to the third phase, which is fulfillment and validation of the charter that we developed up here. This is where we start thinking more than just evaluating. Remember in CRISP-EM, we just had evaluate, but now we're going to kind of test our scalability. And we're going to also start saying, hey, this isn't just a one-off study where we're producing data. We're integrating that data. We might have a customer profiling example where we want to locate or identify the types of customers who are most profitable in our store. And once we find that combination of customers based on their demographics and region and spending patterns and whatever else, we want to locate more customers just like them. So then we're going to generate a mail list, sometimes called a mail blast, and that's an integration. So making sure that the output of our study can be fed into the mail blaster, that's something that we'd validate here before we get to the deployment phase. We also might say, hey, if profitability for a certain region or a certain set of products is at risk, we want to send an alert to our business dashboard in some way. That's another thing that we can do. It's more than just visualization these days. We're actualizing those results in the variety of integrations. Okay, and I just wanted to mention also that the feedback here is similar to CRISP in that it goes back to the drawing board, but also we have this shorter feedback loop where we can iterate between the fulfillment and the data wrangling. So if we learn that the valuation is good, but it's not going to scale, maybe a better example would be once we introduce a lot more data, we discover that some of the data has noise. We get into the idea of feature engineering, which is a data science tedium, if you will. Which columns of data are going to be the most successful in producing the conclusions that you want, theoretically and in practice. So by this point, you've done the theoretics, but by the time you get down here and you have more data to test, you might discover that a lot of the columns or some of the columns might generate noise, so you want to get rid of them. So that brings you back here to the wrangling and refinement stage, you don't have to go all the way back to the charter. All right, now the last phase here is implement and improve. And in order to make this feedback loop actually work, like we discussed before, you need some kind of monitoring framework. This monitoring can identify model drift, and we'll discuss certain tools that allow that to happen. Obviously, for continuous integration and continuous deployment, you have certain features here in CRISP that you identify. You identify internal operabilities as well as external interactions. The external interactions might be data sharing opportunities with external companies. You might want to see, oh, you've improved your data catalog based on consumer insights, so that you have more cross-selling and upselling opportunities. Now you want to share that with your consumer organizations. So that type of work would be considered an external interaction. So these checkboxes exist in SEAL, and they just make sure that people are addressing the environment holistically. Okay, I guess this pretty much covers SEAL itself. Feel free to investigate the white paper. It'll probably clear up any additional details that you might need. Now let's get into a little bit of emerging tech. I think I have about 3 minutes to make this happen. Right, here is a Gartner example of why we need some kind of emerging tech, because eventually the concept of innovation tapers off. So the design thinking trend is to introduce new products over a period of time to kind of take over for the products that have died off, or at least improve the products with major releases. Microsoft is a great example of a company who has kept up with the times, and they know this curve inside and out. This diagram is kind of complex, but I just wanted to have it here so that people can come back and look later. It identifies the data journey and the tools that are used in different phases, right? Here we have all our inputs, and over here we have the analytic tools that we are probably more familiar with, right? We talked a little bit about Alteryx for citizen data science. We have Python and R and Jupyter notebooks and Spark and whatnot. Data Robot for Auto ML. It's a great tool we'll talk about soon. Down here in the traditional analysis and visualization, we have Tableau and Power BI. But all this in-between stuff is important to know where these tools and technologies fit in. We talk a lot about Hadoop. That's basically where we're storing data. And we also store data in CSV and Parquet files and so forth in our lakes, which are organized into S3 file systems or HDFS file systems. In the case of Hadoop, in Microsoft Azure, the Azure Data Lake Service, basically. And then we have our hubs. We talked a little bit about MemSQL, Postgres, and MySQL, and Oracle, and SQL Server. We talked about that's all here, but the more modern hype is leaning toward products like Snowflake and MongoDB for semi-structured data. This is where the hubs and data marts reside from our previous diagram. We even see streaming data, coming in from Kafka and Spark streaming and so forth. So now you get an idea of where these different technologies fit into our landscape. This is just a diagram to justify why DevSecOps is so important as part of our life cycle, and why we incorporate security into it as well. We call it DevSecOps instead of just DevOps. Also note that monitoring occurs in not just the operational environment, production, if you will, but also even in development. Okay, here are some tools to cover. I don't know if I have time to get into too much detail here, but let me just make some highlights. We talked about Alteryx from a citizen data science perspective. It's Gartner MQ rated. It's fabulous. A lot of drag and drop. support, and citizen data scientists and formal data scientists can share the same environment, the same data assets, the same workflows. Data robot is another way to accelerate AI. It takes a lot of the tedium out. Okay, so the feature engineering process that we talked about earlier is a very tedious process. All this model selection is also a tedious process. You know, if you choose the wrong model, you're going to get bad results. And then you have to go back to the drawing board and have another model. So auto ML programs like Data Robot make that happen really fast. Data virtualization, very important topic. Let me just go back to this previous slide and show you what I'm talking about. All these different data sources here that you're feeding into your analytics toolkit, if you will. Instead of having different types of connections to everything, importing files is one way to get data. Accessing the API for MongoDB is another. Using JDBC connection for Snowflake is another. And each one of these sources might have tens, hundreds, or thousands of tables or collections or data sets that you're analyzing. Wouldn't it be nice if you can make all of this look like it's under one umbrella with one JDBC connection and run SQL against it? And when I say SQL, I mean if you're analyzing a Parquet file or a spreadsheet, you can run SQL to query it with a product like Denodo. Let me take that one step further. There's another product called Liftron, which is about 25% of the price of Denodo. That's also great at doing this. Denodo is somewhat more mature. It's a Gartner MQ rated product and has other advantages such as the ability to actually write data as well. So you can write a SQL statement, insert into whatever, and even if it's a data file, or Spark or whatever, it'll generate the code that's necessary to make that write operation happen. Liftron is fabulous. It's very mature for its age, but doesn't have write support yet. Delphix is another type of data virtualization tool, but it doesn't actually virtualize the data despite the lingo that you'll see on their website. What it does is it clones the data virtually so that I can create instantly a copy of my production environment and use it for testing, training, whatever purpose. Great in that respect. Magpie by SelectIS is a great tool for data exploration and preparation. It's all based on Spark. And then we have some tools here. I don't have the time to get into it. I guess a couple callouts really quick. Data Robot is also great at ML Ops. Remember we talked about model drift. So in phase 4 of CRISP, you want to monitor the environment and make feedback to your charter phase if you have to go back to the drawing board because of model drift, or if you just have to, part of the drawing board. For instance, the seasonality, has affected data, or a variety of factors. You might have some imputed data that doesn't adapt over time. For whatever reason, you have to go back and select additional columns or unselect certain columns that are causing noise or whatever it is. Model drift and many other optimizations can be detected in an ML ops package like Data Robot. Another cool call out is here with Liquibase, formerly called DataCal. And in a CI/CD environment, it's actually typical. I don't know if a lot of people realize this, but CI/CD kind of has two meanings. The CD part of it can mean continuous deployment, but it also might just mean continual delivery. Let me explain the difference. Continuous delivery is where you're delivering data through the testing phase and making it readily deployable to production. For data-centric applications, that's quite often what happens because there are a lot of dependencies between the business applications or your dashboards or visualizations or whatever, and the structure of data underneath the hood. That all has to be synchronized And in order to do that, it's kind of complex. So you end up delivering data to the point of pre-production, and then the rest of it is kind of a manual process. A product like Liquibase can take it all the way and automate it, just like a web application. Web applications is very common to have continuous deployment all the way to production. So there are products out there like Liquibase that can help that, and it's not very expensive actually. There are other products here that will help you optimize the budget of your environment and so forth. So that's where Cloud Health comes in. Another product to take a look at, I don't think I have it here in the write-up, it's called Cloud Visor. It'll just help you save a ton of money in your your development, test, and production environments by using cost savings plan on steroids, basically. So if you're familiar with AWS, for example, you can save money by reserving your components for a committed period of time, 1 to 3 years, and prepay a little bit or prepay a lot. The more you prepay, the more money you save. Well, Cloud Visor, which is going to be rebranded soon as Zesty, Zesty Cloud or something like that, but cloudvisor.io is a great product because it will allow you to get economy of scale for savings plans, not just owned by you, but owned by other customers of theirs. They virtually guarantee at least 20% savings, and you're very likely to get much more, 50, 60, in some cases up to 80% savings. And they only make money when you make money. They just take I think it's a 20% cut of whatever your savings are. Now we're just winding down. We have a favorite book that I was reading with my daughter. You can see everyone is happy because we've gone through the whole life cycle and we've delivered success in a repeatable fashion. And now let's look a little bit closer and we say, is everyone happy? They still look happy, but there's something wrong there, huh? Yeah, look at that. There's a leak. I remember reading this book with our daughter and thinking, why would this be in a children's book? And my explanation is that success is not always based on perfection. It's just based on excellence. As long as we can execute in excellent fashion and consistently, we're good. And we've accomplished our return on investment goals, our ROI. That's the copyright. Thank you very much, Dora the Explorer. All right, so now we're on to the Q&A session. I just wanted to emphasize, since this is a pre-recorded session, we'll be doing Q&A shortly. We'll segue to Chris's presentation first. But also take a look at the contact information. Remember, the first and last pages of my deck have contact information, so you can get future versions of this deck. You can see the underlying white paper. It has links here to medium.com and LinkedIn. The same article is in both places. You might just find it easier to Google Bertman and SEAL. Bertman is my last name, B-E-R-T-M-A-N, B as in boy, E-R-T as in Tom, M-A-N. And then SEAL, or just Bertman and Analytics. Either way, it comes up first in a Google search. Or Diffuse and SEAL, or Diffuse and Analytics, Diffuse being our company name. And that's it for me. So now I think the next slide is just a little closure here on ConnectDB and ConnectD and success. So now let's segue over to Chris. Thank you very much. Okay, and Christian Bordeaux is back online. He's going to tell us relevant experiences at Nike and perhaps on PlayStation or Warner Brothers. Go ahead, Chris.
Oh yeah, so I have a really good example with one of my employers, Nike. At Nike, I worked at the photography factory where pretty much we photographed everything that was on Nike.com and that went on billboards and so forth. So, given our understanding, the whole purpose of a photography factory is to pump out photos of the merchandise, which is shoes, shirts, and gear. So, that's a basic business understanding, right? So that is the main key performance indicator. And so, one business question that I got was, hey, how many shoes are we photographing week over week, yearly? Are we doing better over time? And so that is understanding the business question. And then now it's like, okay, how do I get that business understanding and convert that to data understanding? What data things do I need? And so for me, originally, it's like, okay, I need to figure out how many shoes that we've shot and how many photos that is, and maybe like a date column or something where I can figure out like, all right, when that photo was delivered or completed. So then we go into our next step, which is the wrangle and refine. And here, now we're going to acquire this data. So now it's like, okay, now where does that data live? And it lived in our application software, which ended up being Redshift. And I needed to do a select statement where I was like, all right, I need to select a date column. I need to select the individual shoe SKU and the number of photos that were published. So now that's the data that I acquired, now I had to prep it. I had to make sure that these shoes were actually delivered versus either a fake job or a job that maybe went wrong and they had to like fix it somehow. So I had to make sure that the data was reliable. And then for this one, I had to blend the data, make sure that the statuses lined up with the shoes and the number of photos lined up with the shoes, and making sure that worked out well. And then we move into the analytical solutioning and the next step pretty much, which is, hey, we need to be able to get consistent results. So making sure that the query works and everything works out. And then we can go to the next step, which is the fulfill and validate charter. And so here we're looking at, in this example, we're visualizing that data. So in the wrangle and refine section, we are able to essentially create like an Excel spreadsheet of just a bunch of dates, a bunch of SKUs of the shoes, so SKU, which is pretty much a unique number identifying a shoe, and then the number of photos that that SKU has shot in what date. So then now it's like, I want to visualize this. I have this spreadsheet and I needed to make it easy for non-technical users to understand this data. And the best way to do that is with a line chart. And so I actually drew out a little line chart here, which kind of explains it. Like, ideally, we want to get to a situation somewhat like this, where we have time on the x-axis and the number of shoes on the y-axis. And then you have a little mark here, which is like COVID or something, and it shows a major drop. And this will allow business users to understand like what the data
can you
is
hold
saying.
up that line chart again?
Absolutely.
I just enlarged it.
So yeah, pretty much this line chart. Our x-axis is time, and our y-axis is the number of photos. And and then I have this bullet point right here, where it's like, oh, this is when COVID happened, when all of the shutdowns happened, and so there was a drop in production. And then business users or like managers can determine like, all right, if we're not shooting stuff, how are we going to manage the budgets? How are we going to make sure that when we do get back online, this is the kind of ramp up time we're going to need. We have all these different SLAs or due dates for these different shoes. And then to the last step, which is optimizing it and monitoring it. So what I do here is just, if I get a crazy spike in my data one day, then I'll know to like, I need to check and make sure that, hey, is this data coming in reliably? Is it correct? And if it is correct, I need to be able to call that out to major stakeholders. And what's great about that is that you can actually create automated messaging systems, which could tell you like, hey, this rose over 50%, and it'll email you, and it'll show you the dashboard there. So that's, I think that's a really good example of how to use this whole SEAL, because no matter what, everything is going to fall into this kind of cycle. And if you always think about your problems like this, then you'll be able to come out to a solution a lot faster.
Okay, well, thank you very much, Chris. Now we're going to segue to your presentation on finding a job, basically, right? That'll be a good thing. Okay.
Absolutely. Hello, everyone. I'm going to be talking about how to become a business intelligence analyst. So who am I? I'm a senior business intelligence analyst at PlayStation, so you guys probably are going to receive your PS5s soon. And I'm also an assistant data analytics teacher at the University of Southern California, or USC. We're known for our football teams. And I'm also a photographer. More on that. So, graduated college in 2016, got my bachelor's degree in marketing. Got my first job in photography, so I pretty much every day I would shoot food. And then I realized that data really drove how well my success was because I could shoot photos all day, any day, but it was like which photos led to the highest engagement. So I created this visualization based off our Instagram likes, and I was like, wow, can I just do this? And so then I landed my first job at Machinima doing exactly that. And this is where I first met Jeff. And so I was a business intelligence analyst. I got to work on all of different various video game properties and trying to develop content around video games and using data to be able to help those teams. Then Machinima was acquired by Warner Brothers. And so this is where I got to work more on Warner Brothers material. So that was Justice League, Crazy Rich Asians, any DC or HBO. Continuing on, then I wanted to continue my education, so I went to USC and got my master's certification in data analytics. And then later, I was one of the top in the class, and they asked me to come back to be a teacher's assistant. So I did in January 2019. And then this is where I landed a really big role, which was Nike in December 2019, where I get to use all of the cool stuff that Jeff talked about. Combine all of that SEAL, crisp, that was like my foundation. And then now that I understood that, it made jumping into this role very fluid. 10 months later, I get hit up by PlayStation, one of my dream companies. And now I work on the PlayStation 5 and making sure that you can buy things there. So, who is this presentation for? This combine data and business, you should. The best solution an analyst will be. That is Yoda. This is for recent graduates looking for an edge in the data job market. Right now, it's booming. You can ask for any price you want, and especially as just a beginner level student, after you watch this presentation, you will have that edge. Maybe you're a data professional and you want to pivot into business intelligence. Maybe you don't want to do data engineering. Maybe you don't want to do data science anymore. You just want to stick to, complete business impact. Or that just those that want to learn how to utilize business and data and optimize those together. So some high-level objectives I want to cover is what is business intelligence? Why do companies need BI? What tools do we use? What do we do day to day? And how do you land your first BI role? So business intelligence analytics is a process of collecting historical and present data, using stats and software to analyze raw information, and after that, deliver insights for making better future decisions. So, you can kind of see this is a very simplified version of what, Jeff showed. And business intelligence is just a piece of that whole system. And that's why this is very simplified. So pretty much we have our SQL databases that we pull data from. We use data visualization tools like Tableau, Power BI, Looker. And then we create reports and dashboards that helps business users make decisions. So for example, remember that chart I showed you, like this one, where it's like, hey, this is the number of shoes I'm making over time. And continuing on. So this is probably, oh yes, Jeff.
I'll just add one quick thing here. In addition to using SQL databases as a source, there are many other sources available today also, obviously CSV files and JSON and Parquet files and MongoDB and Hadoop and whatnot.
Absolutely. We're definitely going to cover a lot more of those later on as well. Because yes, you're right. It's absolutely not just SQL. If everything was just SQL, business intelligence would be super easy.
Remember,
reality.
I'm sorry to interrupt, Chris, but remember, if you're using a data virtualization tool like Liftron or Denodo, then you can make all those different sources look like SQL. So it is as simple as Christian is saying, depending on your ability to use that tool or something like it.
Absolutely.
There's also Apache, not Wrench. There's an Apache tool that actually does some virtualization as well. It's pretty significant. If anyone has questions about it, we can talk later. Go ahead.
Absolutely. Thanks, Jeff.
All right, so this probably looks very familiar. It's a simplified CRISP model. I won't dive in too much into it since we already gone into it. So why do companies need BI? Companies need BI to make smarter and scalable data-driven decisions. Imagine, you're Nike and you make a bunch of shoes, but you don't know how much profit you're making. You need a dashboard for that. You need to understand that in real time, as close to real time as possible. So, some examples of things is like you want to analyze customer behavior, identify ways to increase profit, and optimize operations. So, to the picture on the left, this is a dashboard that I used. Actually, this was my final project from my college course that helped me land Nike. Pretty much, I showcased that I understood data and I understood how to communicate that data via Tableau dashboards. So this dashboard is showing customer performance over a data set that's public, so anybody can get it. It breaks down by number of customers by region, sales like $725,000 of sales, the orders, and so forth. And this scatter plot allows us to see each one of these dots represents a customer, and we can see like, hey, this person bought a lot, it was very profitable. So we want to really make sure that these customers are very well fed, attention and everything. And looking at these customers and being like, okay, why did this guy have a lot of sales, but very not profitable? Like, what is the deal with him? And how do we avoid these people? Maybe there might be a business justification. Maybe this guy, Sean Miller, maybe he's a market share play where they want to just get market share in that region, so they're taking a loss. But it's not all about profit. Sometimes it's about gaining market share. So that's why companies need BI. For here, they can go through here, adjust any of these dates, regions, customer segments, all of these great things, so they can dive deeper into this data. So what tools do BI pros use? So the BI tech stack is, I kind of, it already shows it, but Excel, SQL, definitely. That's like 80 to 90% of my job is in SQL. I use Tableau. It's a data visualization software, so you can use Power BI, which is Microsoft's, Google Data Studio. I feel like everybody has their own visualization tool, but Tableau is the one that's used most in job descriptions. So if you could say, Tableau, plus Tableau it's free. You have Tableau Public, which allows you can just download it and start using it right away. As Jeff has said before, Python, because Python is used in the data engineering set, used in the data analytics set, and you could even use it as a data scientist. I recommend learning a little bit, just understanding what AWS can do. Pretty much, it's a cloud, like the way I see it. It's a place where you can put all your data up in the cloud, so then that way it's not on premises, or you have to go somewhere, plug in the USB, and just have data stream into your computer. And it's just in the cloud. So being able to understand that, oh, okay, cool. It's like a big Dropbox or Google Drive in the online. And then Git and GitHub, you're going to do a lot of technical reviews, like, hey, what does my data look like? What is the data model? And this is typically written in Python or SQL. And typically in GitHub, you can use that to adjust code, and then that way it doesn't overwrite anything. It goes through a process of peer review. So if this is rank ordered from most important to less important, but these are all the most important 6 stack that you'll need. These are the most common keywords in job descriptions for business intelligence and data analysts. So, if you don't even know Excel, I recommend that's a great place to start. Then second, get into SQL, learn how to make tables, learn how to write SQL queries, window functions. And then once you understand that, going into Tableau will be a breeze, because Tableau is pretty much just SQL queries with graphs. And then once you get all that done, you can start taking a deeper dive into Python, which is foundational to how do we even acquire data, how do we clean data, what is data structures, what's a JSON, what's a list, what's a dictionary, and that will really help later on when you develop applications. So yeah, Jeff, you have something to add?
Yes, when it comes to the order of these, I think you made it clear that this is a typical order that you can learn things, right? It's kind of like using a calculator. Before you use a calculator, you want to understand how to add first. Before you start using a tool like Tableau or even SQL, it's often good to understand the concepts of rows and columns and use Excel. Excel goes way beyond that. You have pivots and you can actually do analytics in Excel. But if you want to do the heavy duty stuff and great visualizations, you end up moving down the list. So as far as what's important in a business environment, a lot of business people and analytic people would say, hey, Python, R, Tableau, those are going to be more important than Excel. So there's two ways to look at this list: the learning order and the go-to tools that you use in the business industry.
Absolutely. And even when you do Tableau and SQL, typically, like when I create a visualization, they could still export a CSV or an Excel file, and then the users will take that into Excel, because that's what most people understand. They understand rows and columns, and then SQL is three-dimensional, or it could be multi-dimensional, where you have rows, columns, and multiple tables, and then you join tables and all that great stuff. That's pretty foundational. But cool, Jeff. I'm going to go ahead and take a step. Next one. So, thank you for that. So, what do BI analysts do? This is one of my favorite sections, and this is very similar to what Jeff was saying. So, earlier in my career, I did a lot of Excel reporting, and so this really helped me understand like what rows and columns mean, how to get data inside, but ultimately really inefficient. So, pretty much, I would take from one of these data sources and make an Excel export, and I would open up probably like at least 5 sheets, VLOOKUP them across everything, and then they would be really slow. A lot of potential human error from doing a wrong VLOOKUP or downloading the wrong data set at the wrong time. Then once I get all that data together, I can finally analyze that data and then deliver it via any kind of email service. So then when we look on the right, which is a lot of what Jeff has showed, and this is a simplified version of this just for business intelligence purposes, is we would put all of these data sources into an S3 bucket, this is Amazon, and then on top of that S3 bucket, we would put it into Redshift and tables that helps us understand that data in a more, for example, we would make fact and dimension tables. Kimball is a very big one for creating dimensional tables. Then we would use Python and Airflow to continually update these processes. Like, hey, give me new data into my S3, and then push that to my Redshift. That just keeps my data fresh. And then what's so great about this is that you literally just plug in your Tableau, Power BI, or Google Data Studio into that Redshift instance, and it creates automated reports for you where you create it once and you're done, essentially, versus over here on the left, I'm having to do this every single day. And then, this process easily took me 5 or 6 hours every single day. This process will take me around 3 hours, and I'm done forever, and I can continue making multiple reports. So for example, like at Nike, there was this instance where we had 3 reports that would take, 6 hours a day. And it was this process right here, all Excel. And afterwards, after I got there 3 months in, I automated those 3 reports, plus I automated 40 other reports that they didn't even know they needed. So the value is so vast, and that's why people pay top dollar for this stuff, because if 3 people were making 100K a year, that's 300K, and they're only doing 3 reports, that's 100K a year per report. If I could create 43 optimized reports for the measly small price of 100K, that's an extreme value for the company. And I've since then been able to surpass the 6-figure mark because of the value I'm adding. So pretty much, go ahead, Jeff.
Can you go back to the previous slide?
Oh, absolutely.
All right. Just to correlate this to the past presentation, you'll remember the technical landscape diagram and all the purple dotted lines, for example. The S3 storage here is basically analogous to the data lake in that diagram and in industry jargon in general. So that's one key architecture to support your data lake. The Hadoop file system is another popular data lake storage platform. Technically, you could use an NFS file system, but that's not really common, particularly in the cloud environment. And remember, these cloud environments like Amazon, you can actually have an Amazon outpost and implement certain technologies from AWS on premises. So some of these actually convey to the on-prem environment. So S3 is analogous to data lake. AWS Redshift, Amazon Redshift, corresponds to the data hub or data warehouse that we were talking about before. And what Chris pointed out with executing that 5-hour process over and over and over again on the left versus making it a one-time 3-hour process and then you're good forever, that relates to the shortcuts that I was talking about. When you are tempted to make a shortcut and go for the data directly, you're going to take that one-off and do it over and over and over again versus taking a little bit of extra time and putting it into your hub so that you can make it a repeatable process, and that's what makes life cycles very productive. I'm not saying you can't have one-offs, they're there for a reason, but at the end of the last phase in the SEAL life cycle with the continual improvement, you say, hey, should I now integrate this in the next phase so I can do future year-over-year analysis, month-over-month comparisons across segments or whatever you want to do without reinventing the wheel each time, or without losing track of the data, which happens a lot. And you have these data silos that you forget about, and then they don't even end up getting used anymore, but you're paying for all that extra space. So there's a lot of reasons to focus on this right column that Chris has here. It's great. Thank you, Chris.
Thank you, Jeff. Thank you for adding that color to that. So, it's very similar to Jeff's presentation. This, it's obviously all green for the BI side. It's more resilient, it's more flexible, you can automate things, the running cost is less, and the security is greater, because if you just do everything in Excel, that Excel file can be leaked via email. But in business intelligence and Tableau, you can set rules and regulations like how only this email address can see these level of rows. Like, let's say you're a director, you need to have a different level of access versus somebody that just needs to view the data. Yeah. So, I've already enticed you, you're sold, and now you're like, all right, how do you land your first BI role? So I kind of want to take it from like, how did I do it? So while searching for work, I read 100 plus personal development books. Because business is connections, business is communication, business is, logic. And so I did this, like 7 Habits of Highly Effective People. It's one of my favorite books. It's pretty much the foundation for every personal development book I've read. And so I did a lot of that. I also watched 500 plus hours of LinkedIn learning, which is it's been also called lynda.com. LinkedIn acquired lynda.com. It's pretty much a MOOC, which is a massive online content. Pretty much here you can learn about SQL, Python, everything. And what's great about these LinkedIn learning courses is that you can get a certification for every time you complete a course. And then you utilize those in your applications and in your resume. I completed a Udacity course on business intelligence. I enrolled in USC's Master's Bootcamp, and I watched over 100 hours of Tableau training. The Tableau training videos on their website are immaculate, and they're so great. You don't need to go anywhere else for the foundational stuff. And ultimately, you do all this learning so that way you can create projects that showcases to your employer that you know what you are doing, and you can effectively communicate that you know what you're doing, because these projects immediately put you to the front of the line, because hey, this guy, even though he has no experience or very limited experience, he could showcase and talk about this project more than what we're used to, or at the level of what we present. So as a result, I got 9 job offers in 2019. I landed a job at Nike and then Sony in July. I quadrupled my pay since Warner Brothers. and I had all to little to no data work experience. When I first landed Warner Brothers, I can talk about that later. I have it in there. Anything on that, Jeff? I mean, that's just like my result, I guess. But
Well, I can personally vouch for Chris's skills and his ambition, quadruple the pay. Nothing better than that. Except maybe 10 times the pay, but I don't think that would be possible.
we'll get there. Maybe if I create a business like you, I can do that. Okay, so how do you land your first role? We're going to talk about these 4 different points. You need to learn the tech stack, create projects, optimize. So these are in order. Optimize your LinkedIn and resume, and then learn how to job hunt. And these are 4 really critical things that you need to do. That they're all deep wells. So let's start into it. So learn the tech stack. So I have pretty much learn Excel, SQL, Tableau, Python. For me, yes, there's alternatives to those pieces, but I recommend you learn those ones. I would recommend learning Excel, SQL. Okay, let's say Tableau, right? I would rather you learn Tableau versus Power BI or Google Data Studio, because in my opinion, it is the best data visualization tool. It is the best combination between design and technical things that you can do. I've used a bunch of different tools and nothing has matched Tableau. And I would recommend learning Python over R due to the data science capabilities you can get into, plus a lot of the data engineering aspects of Python. Python is just a good tool to understand and use. So starting on the left, free. Udacity has a bunch of free courses. Solo Learn is an app on your phone where you can learn Python over time. Really cool. I used to do that on the train when there wasn't COVID. LinkedIn Learning it used to be free, but it could be free at certain places. Like if you get a library card in the United States, you can get it for free. Not sure about that in any other countries. Coursera, you can audit courses. Code Academy, there's a free trial. And then these cost a little bit of money. Like Udemy costs $20 USD typically for a course. And DataCamp, DataQuest, definitely really great. Like they make it a game. They gamify the whole learning experience, which is really fantastic. And Code Academy Pro. And then if you want to really drop the big bucks, you could go to Udacity, get a nano degree. It costs $200 USD plus a month. Or you could drop like 10,000 USD on a data bootcamp. Honestly, I really like the data boot camps because they put you into a social environment and you have peers that can help you immediately versus taking any kind of online course where it's self-paced, because you can start and stop whenever you want with the self-paced, but that's good and bad because then you can get stuck, you stop, and you never learn. But these data boot camps keep you on track. Or if you really just want to ball out, get an MBA in data analytics, spend $40K. I don't recommend that option at all because it's so hard. Data keeps evolving, and you will not I don't know. I don't see the return on investment on that. But I do recommend the data boot camps. But you could get it, and you'll get that MBA on your TAC. But as far as making you more money, that I haven't seen the correlation to that. So now that you've learned all this stuff, now you want to. Oh yes, Jeff.
I just want to make a couple of quick call-outs here. A tip when using Udemy for learning is when you first enroll, you're going to get extreme discounts, and then I think that lasts for maybe 5 days or so, maybe 10. And then the discounts go away, and you see a lot of $200 courses, in addition to certain courses for $20 or $30. But probably about once a month, if you look in your mail, you'll see promotions for drastic sales, 90% discounts and things like that. So then you just go back, and you don't have to click on the mail. You can just go back and visit Udemy periodically if you want. And you will see something, a lot of things significantly on sale. So that's a good way to use Udemy. For DataCamp, I love it because it's totally interactive. So for learning Python, it's all about interactive exercises, whether you're on your laptop or your mobile device, and you literally have to type things in, to reinforce. You're solving this problem. Enter the code. Sometimes the code is partially there, so you only have to fix it or type the rest of it in order to get reinforcement. It's a great tool. And as far as the MBA is concerned, I think Chris is pretty much on target in that it can become obsoleted a lot sooner than the data boot camps. Data boot camps are great for recurring experiences, for keeping up to date. And so are some of these other tools, right? Nonetheless, there's a perception out there, that and for an initial boost, when you're graduating, for an initial launch point, it's good to have a master's degree. I don't want to underemphasize the master's degree and the process that you go through of executing, planning and executing your thesis and so forth is similar to a lot of business processes. So that experience and the professors that you learn and the people that you meet in those environments, they can help you in a lifelong fashion. That's my opinion on that.
Yeah, for sure. I think that's key because you get the network from there as well. So, yeah. So now that you've learned those skills, it's time to create projects because if you're like me, I was a photographer and I did not have a data job. So I had to create projects. Like when I was a photographer, I created that, remember that not pie chart. Oh, there was a pie chart there and a line chart and a bar chart. I created that, and that helped me land my first role at Warner Brothers. I just showcased, I understood data visualization, Excel to a degree, where I knew pivot tables and all these things. And so that was my first project. And, it was perfect timing as well. I had met the VP of Business Intelligence, and I was like, hey, I'm really passionate about gaming, and I want to work where you do and do your job. And he's like, sweet. He saw my passion, and I got the job 3 days later. So, okay, so now you want to create these projects. You don't have a job where you can collect data. So where do you get data? There's data for free on Kaggle.com. It's pretty much a bunch of communities put up data sources up there. They clean it sometimes, and you can just go there. There's data on everything: movies, video games. You want to do fraud analysis. They have credit card information there. Obviously, it's fake, but you can still use machine learning and all those great things. Google data sets also. And, as you get to learn Python a lot more, you can start tapping into various APIs. Google has an API, Yelp has an API, and like Yelp, let's say Yelp, you can find restaurants or, services, and you can create a whole analysis on it. So once you create that project, you want to share that project on LinkedIn, GitHub, and even what Jeff does, he puts it on Medium, which is a platform for putting up blog posts, essentially. It's kind of like, it's literally a blog. And so you could develop a following there. And so when you go onto your resume, it's like, hey, I have 10,000 followers on Medium. And, that showcases that you're an influencer in the space, but two, you also know enough to talk about it. Obviously, use it on your job application. So what I would do is put your whole presentation into a PowerPoint, like a Google slide or a PowerPoint, and export it to a PDF and submit it along with your application. That way, I feel like this is more important than a cover letter because this was exactly what you're going to be doing. Hey, this is the work I've done, and you kind of want to make your projects relevant to the job that you're applying to. So when I went to the Nike job, I had a whole business intelligence process where I pretty much, kind of like in the beginning where you have the red and green process tree, I talked about it and I knew what tools they used because that was on the job description, and I put their tools inside that project, and they were like, wow, this guy's just a shoo-in, let's get him. And I got offered the job right then and there. And but what was cool about that was I actually had 3 offers at the same time, and I was able to negotiate. So negotiate a lot. So that's that's why if you create good projects, people just will want you on that basis. And then they'll interview you just to make sure you're not a psychopath or something. Okay, so we have our projects and we've learned the tools. Now we have to learn basic job hunting. So that's resume building, professional branding on LinkedIn. You could be like Jeff and have over 15,000 connections?
14,000.
14,000. Yeah, sorry, my bad. With my measly 3,000 connections. You use talent agencies. These, I'll get into detail with these later. And network. So these are the 4. We're going to dive deep into each one of these. So resume building. What makes a good resume? What does a good one look like? What should I include on it? And so forth. So obviously this presentation, I can't go everything into a resume, but I do want you to look at these 2 separate resumes here. So this is the same guy, same information, but 2 separate resumes. And so, usually in an in-person event, I would ask you, which one do you think did better? Which one got the job? Was it this one or this one? So to make it simple, pretty much this one on the left was actually the one that got him the interview and got him the job. And I'm going to tell you why. So this is the resume for me that got me Nike. And I told him about the formatting of this and why it worked and why it is the optimal way. Because when you apply to a job, a human like me and you do not read these raw resumes. What they go through is a system called applicant tracking systems, where they parse out the keywords in your resume and it puts all the resumes so that they look very similar, and then they can search through it using keyword searches. So for example, if you're at a Disney or you're a Warner Brothers or you're Nike, you use these systems because there's thousands of people that apply to these jobs. There's no way that one recruiter is going to look through thousands of resumes for one job opening when they probably have 7 to 8 job openings. So that's 7,000 resumes. They're not going to be able to do that on top of the other things that they have to do. So technology has made it easier for them where they use these applicant tracking systems. So essentially what I'm saying is you want to make your resume as easily readable to these applicant tracking systems. And how do you do that? I separate everything with pipes. So I live in Los Angeles, pipe, my phone number, pipe, my email address, pipe, this. And so I follow a similar format. This is for readability for the user. It's all right, here are my data visualization tools, here are my data wrangling tools, here's all different SQLs I've used, and blah, 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 blah. Work experience, I put my title first, and then the company, and then where it was, and then the date. And then what they're able to do is really see how much experience you have in something. They have visualization tools which says that, hey, they actually only have I think this is 3 or 4 months. They'll see that 4 months of experience, and then they're all right, they're going to add that to this, this is a 2 months of experience plus 10 months of experience, and they'll add up all those numbers together and then come up with hey, this person actually has a year or 2 of experience. And so that's what's crazy with the parsing tool. Plus, I added my business analytics project at the bottom because I also attached it to my resume. They're oh yeah, what is this? They used all the tools that I use. And yeah, then I put my education last. Typically, if you're just coming out of college, I like to put my education on top, but I had a couple months of experience, so I put it straight to the bottom because education is just a checkbox on a resume, because they really just care if you can do it, not necessarily did you graduate from a college. So that's my tips on resumes. Obviously, there's a lot to it, but this is what it should look like. At least you can get started. Literally just copy this. This is on my Google Sheets or Google Docs. And I like to keep my resumes on Google Docs because I can edit it anywhere, and I don't need to have Word. I can edit it on my phone if I want to. So, anything on that, Jeff? Resumes?
Yeah, I just want to say, I understand what you're saying about education being a checkbox, from the job reviewer perspective. The need for education and formal education in a college university environment is absolutely compelling, to me, particularly the undergraduate, but even in graduate school, the exercise of going through a thesis and certain things has a value. It depends on the person, right? Like you said, early in your career, you put education first when you're first entering the job market, so everyone can see, hey, I'm done, right? So from the I'm done perspective, it's good to see that at the top. I think that's what you meant, versus the casual checkbox thing. I just want to make sure that our audience understands that because a lot of them are in the college environment now.
Absolutely, yeah. I mean, yes, that's why it is super important right when you come out of college, but when you get experience and stuff, let's say I graduated 20 years ago, the degree would mean a lot less. So yeah, but it does mean a lot when you just get out. Yeah. So continuing on. So LinkedIn tips. Fill in everything. So that means put a headline, put a summary, put your picture up there. Like that's the most important. Customize your URL. So a URL is like the link of your LinkedIn. You want it to just be like linkedin.com/Christian Bordeaux or whatever your first and last name is. That way it's more professional. Like when we go to like the resume, like it'll look like this. It'll be LinkedIn Christian Bordeaux versus LinkedIn Christian Bordeaux 71500051332X, and it just doesn't look professional, and it just shows that you care about your branding. Definitely turn on looking for job opportunities on LinkedIn. There's this little box at the bottom where you can check. And this will allow people on LinkedIn, like so recruiters that are looking for people to hire, they go into LinkedIn and they just search up Tableau, and they look up everybody that has Tableau on their webpage or their landing page on LinkedIn. And if they see that you're looking for a job opportunity, they'll reach out to you and be like, hey, I have this opportunity that I think you'll be a good fit for. And then you start talking to them and you start, like get on the phone with them, talk to the people. And then, that's how I got all of my jobs actually. After Warner Brothers, I got all of them through LinkedIn. So I think that's a big key thing. Get 500 plus connections. This just shows that you like using the LinkedIn tool. Plus, it showcases that you network, and the 500 connections is relatively easy. Just connect with people. I mean, you could even just say like, if you really wanted to connect with data influencers, connect with everybody on this this conference essentially, and just like, hey, because like you go and see them, like you want to support them by connecting with them as well, because then your post gets seen on their page. So yeah, those are like just key like 4 high level tips. Again, I could do I have done a whole course on LinkedIn. Any tips from Mr. 14,000 followers?
No, that's good. I think you did a great job on LinkedIn.
All right, thanks, Jeff. Okay, this is a big one. Use talent agencies. I know in the U.S. we have them, so I'm not sure. You have to check with your local piece, but their job is to find you a job. So they get paid when you get paid. So pretty much it's a win-win situation where they're looking for work for you, and once you get the job, let's say the job is $100K a year, they're going to get you that $100K a year, and let's say like Nike, right? They're going to pay that talent agency a finder's fee. So you're going to get paid the $100K a year, and you're going to be able to get that job, and it's really great. They get paid when you get paid, but the thing is, there's a high cost, right? You have to make sure that you're marketable online, especially with COVID, because you're not meeting anybody in person anymore. Your digital profile is your selling document. That is you. And if your LinkedIn doesn't look great, you don't have a photo on your LinkedIn, trust immediately is lost. So make sure you have a LinkedIn, like get your iPhone or get any phone and take a picture of yourself and have somebody else take a picture of you, just so that you can see your face clearly, and put that up there. It's a lot simpler than people. You don't need to have a professional camera, professional shoot. You just get your photo up there. But that's what I see a lot when I talk to my students. So here's a list of agencies. Definitely recommend screenshotting or saving this bad boy. So network and be part of a professional org. So you guys are doing a really great job already. You guys are here at this conference, and now it's just start to network. So here's some bullet points I recommend to network effectively. So go to data relevant events. Like obviously you're here at Con CD and DataCon LA. There's a bunch online. Participate in data user groups like meetup.com. I know Jeff has a lot of experience with meetup.com. Do you want to dive into that a little bit?
It's definitely a go-to place for a user group experience where you can find out who in your local community is trying to set up a user group, already has a user group, and has a calendar of events set up. So it could be very high level on the topic of data science, for example. It could be low level on a specific topic, like maybe just data robot, maybe just Spark, maybe just Presto. So the beautiful thing about Meetup is that there's all levels there. I appreciate it.
Yeah, and not only like now today with COVID, it's not just local. It could just be like there's a Zoom meeting at 1 p.m.
Right.
PST, and now you can be part of this big group. And I find a lot of, I surround myself by people that I want to be like. That's why I surround myself with people like Jeff. The more, there's a saying, you're the summary of your 5 friends. And so if you want to be really good at data, you have to surround yourself by people that do data. And that's why networking, you have to network. It's not like, oh, my skills will sell itself. Network in order to get even higher level positions. So be prepared. So when you network, be prepared to sell yourself. You have to have your resume ready, your LinkedIn ready, business cards for in-person stuff, and just research. When the VP of Machinima came and talked to our, it was an in-person event in like 2017 or something. And I downloaded his LinkedIn and I took notes when he talked. And I made sure that after the session was over, I made sure I went up to him, talked to him about very specific points in his presentation, and talked about his history, like, oh, that's crazy how you went from this to here. And so, for him, he was like, wow, wow, you did so much research on me. That's, he appreciates that. And then, I got the job. And that kind of goes to my next part. Have an elevator pitch, especially as a student, when you're approaching these networking events, come at it from a student perspective. It's like, hey, I'm a student and I'm graduating soon and I just want to learn about what you do. I'm graduating in 2020 and I'm looking for different job prospects and I'd love to have an informational interview with you where I get to learn about what you do day to day. That's why I do these presentations, because I get asked a lot, like, what do you do? How have you had your success? And this is my medium of trying to get as many things as possible so I can just point somebody to a YouTube video. But as a student, just say, hey, I'm a student and I want to learn more. Talk to people and connect on LinkedIn. This one's easy and you have to do this nowadays. It's just, LinkedIn is so easy, and plus you can't go outside in most countries, especially in the United States. It's like they're pretty bunkered down. And there's no events where you can go to, no in-person events, because you can't congregate for more than 10 people. So this is another thing I would recommend. Schedule Zoom sessions or phone calls with people and just learn about what they do with their job, because maybe like you want to become a data scientist, but then you learn about what it takes to be a data scientist and you're like, maybe I want to become a data engineer or a business intelligence analyst. And so like this would be a good way for you to create that path to where you want to go. And ultimately, always ask for openings at their work. You never know. Like at Warner Brothers, when I recommended somebody to work, like I got a little stipend. So like that was like a win-win situation for me. So in conclusion, to summarize everything that we've seen here today, focus on learning the foundations of data, along with widely used tools like Excel, SQL, Python, Tableau. Utilize projects to fill in that experience gap and learn the tools. And then develop your personal brand to reflect your data expertise, even if you have no experience. So let that one sink in. You don't need to have work experience in order to get these jobs. I personally believe you just need to have a project that can showcase your experience. So this is where I have a Q&A, but you can take out your phones here and you can connect with me on LinkedIn on this left QR code. And if you want the presentation slides, feel free to just scan here and you'll be able to see it. So Concat CD, thank you for having me. Jeff, thank you for having me as well. And I'm definitely looking forward to connecting with all of you on LinkedIn, and feel free to DM me and I can get back to your questions as they come in. Thank you.
Okay. All right. Perfect. Well, thank you very much, everyone. Take care. Have a great day, and enjoy the remainder of your sessions at Connect E or CD.
Nice. See ya.